In this problem, we are asked to determine several parameters. We are given a reaction, and we are given the rates for the forward reaction in the absence of the enzyme and in the presence of enzyme. And the first question that we need to determine, we need to answer, is to calculate the rate enhancement by the enzyme. So we know that rate enhancement can be determined by the ratio of the non-catalyzed and enzymatic reaction. So we will have a rate for the enzymatic reaction in our enumerator divided by the rate of the forward reaction in the absence of the enzyme. And in this particular case, we will have 5 by 10 to the power of 6 inverse seconds divided by 1 by 10 to the minus 2 inverse seconds. And it will be equal to 5 by 10 to the 8th. Of course, unitless, because inverse seconds will be cancelled out. So we know that from that we can actually calculate the or estimate the decrease in the activation energy that enzyme achieves, right? But here we're not asked to do that. We are asked to determine the equilibrium constant for this reaction if in the presence of the enzyme, if in the absence of the enzyme it is equal to 1 by 10 to the third. So we know that enzymes, so if you draw or sketch rather the energy diagram for this reaction, and for example here is, because K equilibrium is higher than 1, it means that the reaction is thermodynamically favored. So here we have our A, here we have our B, and in the absence of the enzyme, the transition state is here. And so we have something like that. And in the presence of the enzyme, we have much lower activation energy. But the enzyme doesn't change the difference between the energies of the reactants and products. And this is actually my delta G. And we know that delta G depends on the equilibrium constant, right? As minus RT logarithm equilibrium constant. So if delta G is not changed, K equilibrium will not be changed, right? So it means that it doesn't matter if it's in the presence or in the absence of the enzyme, the equilibrium constant will be the same, and it will be 1 by 10 to the third. And since the equilibrium constant is the ratio between product and reactant concentration, it will be unitless for this particular reaction.